So we're trying to set up an experiment where we can measure the speed of the wave. Now, wave speed is frequency multiplied by wavelength. So I can use my board here to set up a wave. It's very high tech, as you can see. And I'm going to take a photograph of that in a minute so that I can actually get a ruler out and measure the wavelength. What I'll need to do before I actually do that is put a scale in the picture. So now to the way that we're going to work out the wave speed using our very basic setup in the bath. Now that method has a numerous inaccuracies in it. So there's a few things I've done to try and overcome that. To remind you, wave speed is equal to frequency times the wavelength, which is V equals F times lambda. To remind you as well about the units, our velocity, our speed is meters per second, our frequency is hertz, and lambda, our wavelength, is in meters. So here is a photograph, one of the many photographs I took to try and capture the wavelength or the distance between two of the waves. So I've marked it up in two locations, and that essentially is the peak of one of the waves, a wave apart. I had my scale, a ruler, in the bath water, and you can see the difference between them. So 14.7 to 25.9, and that's a difference of 11.2. So the first wavelength measurement I've got is 11.2 centimetres, but I've got to divide that by 100 to convert it to metres. So what I've actually got is 0.112. Now, as I said, the way that we've done this experiment as needs must is inaccurate. So I've actually got 5 different photographs and I've got 5 measurements of wavelength, which I'm just writing down now. And I'm going to take a mean from those as well. So that comes to 0.902. If I take the mean by dividing by 5, what I end up with is a wavelength average of 0.18 meters. Now, in terms of frequency, the other thing I did was to take a stopwatch. I used my phone to do that, and I counted how many waves went past a point in 10 seconds divided by 10. I'm very lucky because actually it was 10 waves on average per second. So if I have 10 waves divided by 10 seconds, I end up with a frequency of 1 hertz. To go back to my formula then, and to substitute my numbers in, my wave speed is now going to equal 0.18 times 1, which gives me a wave speed of 0.18 meters per second.